Hi, good morning, boys and girls. Today we're going to work on Module 13, Lesson 5, which is Express Whole Numbers as Fractions, and your lesson starts on page 369. Okay, the I Can objective says, I can draw visual models to show how to write fractions that name whole numbers. Okay, let's take a look at the model on the bottom. We see that we have 5 stars, and the question says, what fraction of the stars are striped? Okay, and the answer is up there for us, but let's break it down. We see 2/5. We know that the bottom number, or the denominator, tells how many equal parts are in one whole, and if I look at my model, I see that there are 5 equal stars in that one whole. And then the number on the top, or the numerator, tells how many parts are being counted. And in this case, since we're looking for stars that are striped, there are 2 stars that are striped, giving me a fraction of 2/5. So 2/5 of the stars are striped. Okay, boys and girls, now let's take a look at the number line that you see on the screen. And I'm going to fill it out, and I want you to see if you can find my misconception. So I know that I'm starting at 0 and I'm ending at 1. So I know that the space in between is one whole. Okay, so now I'm going to write my fractions and I'm going to decide my denominator. So I'm going to count 1, 2, 3, 4, 5, 6. I counted 6 lines, so my denominator must be sixths. Okay. I'm starting at 0, so I know that my first line counts 0/6. My second line counts 1/6, 2/6, 3/6, 4/6, and 5/6. Can you tell me what mistake I made? What is the misconception that I have about my number line and these fractions? That's right. Boys and girls, I counted the lines in my whole instead of the parts. I need you to remember that when we are working with fractions, the denominator counts how many parts are in a whole. So I'm going to go ahead and I'm going to erase my mistakes, and we're going to start again all together. Okay? Now let's count our spaces. I like to draw jumps on my number line, and that'll show me how many parts are in my whole. So I see that I have 5 parts in my whole number line, so that would make my denominator 5 in each of my fractions. Okay, and again, since I'm starting at 0, I have 0 parts, so my first fraction would show 0/5. Okay, once I take that first jump, I have 1 part out of 5, or 1/5, and my second jump, I have 2 parts out of 5, or 2/5. In my third, I have 3 parts out of 5, 4 parts out of 5, and then I have all 5 parts out of 5. So the black dot is representing 2/5 on my number line. Okay, and remember, boys and girls, you can always go ahead and think about it as a bar model if you're having a hard time picturing the parts in a number line. Okay, and you see how my bars here, my parts here, equate to my parts on my number line. Okay, boys and girls, we're on number 1 on Build Your Understanding. I'm going to read the problem, so follow along with me in your books. Tristan makes circular pans of cornbread and cuts them into thirds. So I know that Tristan, he's making cornbreads, and my pans are circular. If I didn't have that model showing me that it's a circle, I see the word circle in circular, so I'm imagining that my models are going to be circles. And I also know that he's cutting them into thirds. And I know that thirds is a fraction with a 3 in the denominator. So I know that his model, or his cornbread, is going to be cut into 3 equal parts. Okay? Start with letter A. How can you show 1 pan of Tristan's cornbread cut into thirds? How can you show 2 pans cut into thirds? Well, let's start with the first question. It's asking me for 1 pan of Tristan's cornbread cut into thirds. I know that his cornbread is a circle, so I'm going to go ahead and draw my circle. And it's cut into thirds. I know that when I'm cutting it into 3 parts, I want to make sure that those parts are equal. So I'm going to try my best to make 3 equal parts in my model. Okay, so I think that's showing 1 pan of Tristan's cornbread cut into thirds. And now the second question is asking me how you can show 2 pans cut into thirds. Well, I just imagined that I would draw another circle that's the same size. Okay, and again, I would take this one and equally cut it into 3 parts. Okay, that's showing me 2 pans of cornbread, and each one of those is cut into thirds. Okay, how many thirds are in 2 pans? Well, I know that I'm counting by thirds, and each one of those pieces is 1/3. So let's take a look. This piece is 1/3, 1/3, 1/3, and those are my unit fractions. And then I have 1/3, 1/3, and 1/3. And I want to know how many thirds. Sometimes looking at fractions in words is actually easier, so let's just count them. We have 1 part, 2, 3, 4, 5. There's 6 parts, and each of those parts is a third. So we have 6 thirds. Now let's turn those words into an actual fraction. So how can you write this amount as a fraction? Well, I know that if I'm talking about thirds, my denominator would be a 3, and I have 6 of those parts, so my numerator is 6 thirds. What whole number does the fraction equal? Well, we have 6 thirds, and that equals 1 whole and 2 wholes. So 6 thirds equals 2 wholes. What do you notice that's different about 6 thirds than other fractions that we've been working with? That's right, other fractions that we've been working with, the numerator has always been smaller than the denominator, which gave us an amount that was less than 1. But in this case, we have a numerator that is bigger than the denominator, which means that there's more parts than you need for 1 whole. So if you have more parts than you do for 1 whole, then you're going to have something that's greater than a whole. And in this case, you have 2 wholes. Now let's take a look at number 2, and I want you to follow along while I read it. How can you name the points located on the number line using fractions and whole numbers? Complete the number line to name the points. So boys and girls, this one I'm going to break it down a little bit. I have been very specific to say that the denominator is how many equal parts in 1 whole, and I've said it's going to be really important later on, and this is one of those times that it's really important. If you take a look at the number line, we start at 0, and then we have a 1 right here. So the entire number line is equal to more than 1, but we're going to focus first just on the parts that equal 1. And if we take a look at that 0 to 1, we see that there's 2 parts that equal 1 whole. So A asks you, how many equal lengths are there from 0 to 1? There's 2 equal lengths. Okay, those 2 equal lengths make 1 whole, which is why our denominator is a 2. So they're broken up into halves. Okay, what whole number and fraction represents 4 equal lengths? Well, let's erase this and start over. Okay, what whole number and fraction represents 4 equal lengths? Well, let me make 4 jumps on my number line. 1 part, 2 parts, 3 parts, 4 parts. Okay, so those are 4 equal parts, and I want to know what fraction that represents. Well, let's start with a fraction and let's see. If we start here, we know that that would be 0 halves. Okay, our first jump is 1/2. Our second jump is 2 halves. Our third jump would be 3 halves. And our fourth jump would be 4 halves. Remember, our denominator isn't changing because we're not changing how many parts there are in one whole. The only thing that's changing is our numerator, or our top number, because we're adding 1 extra part each time that we make a jump. Okay, so now let's take a look at the whole numbers. Well, we know that 2 halves equals 1, because if you're breaking something into 2 parts and you're counting both of those parts, you're counting the entire thing. Okay, so then 4 halves, which is 2 more parts, would give you 2 wholes. Okay, if you have another 2 halves, then you have another whole. Okay, so what whole number and fraction represent 4 equal lengths? So 4 halves and 2 wholes. Those are the 2 numbers that represent 4 equal lengths. And the last one, C, what whole number and fraction represent 6 equal lengths? So we know that we stopped at 4 equal lengths right here, and we're just going to add 2 more equal lengths, 1, 2, or 2 jumps, and we're going to continue naming our fractions. So we were at 4 halves. If we add 1 more part, we're at 5 halves. Okay, and then 1 more part, we're at 6 halves. And if we look at our whole numbers, we were at 1, and then 2, and then 6 halves would be 3 wholes. So 6 halves Okay, so 3 wholes looks something like that. We know that 2 halves equals 1 whole, 2 halves equals 1 whole, and 2 halves equals 1 whole, so we have 3 wholes. And 3 wholes, or 6 halves, represents 6 equal lengths. Okay, I want you to take a look at 4 halves. And I want you to take a look at 6 halves, and I'm telling you that 4 halves is 2 and 6 halves equals 3. Is there a connection to division that you can make with 4 halves and 6 halves and what they equal as a whole number? That's right. 4 divided by 2 equals 2, and 6 divided by 2 equals 3. So there must be some connection between fractions and division. Okay, boys and girls, let's look at number 3. In class, we would do the 3 reads. So I'm going to do the 3 reads and discuss what the situation is about. Tim uses 4 tortilla halves to make tortilla chips. Rita uses 9/3 to make her tortilla chips. How many whole tortillas do they each use? So I see that the situation is about, there's 2 people, they're making tortilla chips, they're using tortillas, and we want to compare how many wholes they're each using. Now I'm going to do the second read, and let's think about the quantities that we see in the problem. Tim uses 4 tortilla halves to make tortilla chips. Rita uses 9/3 to make her tortilla chips. How many whole tortillas do they each use? So I see a quantity of 4, but it's not 4 wholes because it says 4 tortilla halves. So I know that halves is something that's broken up into 2 equal parts. And then Rita uses 9/3. Okay, and I know that thirds tells me that my denominator would be 3 because there would be 3 equal parts in one whole. And the question is asking how many whole tortillas do they each use? Draw to show each fraction. Okay, here's where you would do the third reading on your own, boys and girls, but I'm going to start my model. Okay, I know that I want to keep my work organized so that when I look at it, it's easy for me to identify each person and how they're cutting up their tortillas. So I'm going to start off with Tim. Okay, and he uses 4 tortilla halves. So I know that when I see half or halves, I know that it's a whole broken up into 2 equal parts. So I'm going to go ahead and draw a tortilla or a circle. Okay, and I know that his tortilla is broken up into 2 equal parts, and I have 2 halves. But the problem is saying that he has 4 halves. So I know that I have to go ahead and draw another tortilla. Okay, and I'm going to cut this up into 2 equal parts. And it looks like I have 4 halves now. So that would be the model for Tim's. Now I'm going to use another color, and we're going to go on to Rita. Okay, and I want to make sure that my model shows that the circles are all the same size. Tim and Rita probably have the same size tortillas. We weren't told otherwise. So I'm going to go ahead and draw my first circle for Rita. Okay, and I'm going to cut hers into thirds. So I want to try making 3 equal parts, as equally as I can. Okay, and that would give me 3/3, but she has 9/3. So let me draw another one. Okay. And that would give me 6/3. So I don't have enough just yet because I have 1, 2, 3 parts, 4, 5, 6 parts, and I need 9 of those parts. Okay, and 6 parts, 7, 8, 9 parts. So now I'm showing 9/3. Okay. A says, what fractions represent Tim's chips and Rita's chips? How many whole tortillas does each fraction represent? Well, we know that Tim had 4 halves. Okay, 4 halves. And if we look up at our model, we see that that means 2 wholes. Okay, and then Rita had 9/3. And if we look up at our model, we see that that's 3 wholes. So how many whole tortillas do they each use? Well, Tim uses 2 wholes. And Rita uses 3 whole tortillas. Okay, boys and girls, so we're going to pause here to give you time to do the check understanding and the on your own. If you take a look at page 371 and 372, you'll see both of those parts. You can pause the video here and come back when you're done to see how you did. Okay, welcome back, boys and girls. Let's take a look at the check understanding. Let's start there. Number 1 says, each circle is 1 whole. Write a whole number and a fraction for the parts that are shaded. Well, writing a whole number, pretty easy. We look at the circles and we see that there's 2 whole circles. So my whole number would be 2 whole circles. Okay. And now, looking at the fraction, we see that they already gave us the denominator. And the reason that the denominator is 6 is because there are 1, 2, 3, 4, 5, 6 equal parts in 1 whole. Okay, so my number is 6 on the denominator. And now to look for the numerator, I'm going to count how many parts there are in both wholes, okay, in the whole model. So I know that I have 6 in the first, and I know that I have 1, 2, 3, 4, 5, 6 in the second. So I have 12 parts, 12 equal parts. So I have 12 sixths. And you should be able to start making that connection to division. So 12 divided by 6 equals 2. So I see that connection there again. Okay. And now on to the on your own. Okay. Number 2 says, Peter uses 8 1/2 fraction circle pieces to make whole circles. Show the whole circles that Peter makes. So I know these, we have them in our math tools, okay, and they look like this. So I'm going to make 8 1/2 fraction circles. So they look something like this. So that's 2 half circles. 4 half circles, 6 half circles, and 8 half circles. So if I take those half circles and I put them together, I'm going to make 1 whole circle, 2 whole circles, 3 whole circles, and 4 whole circles. So Peter makes 4 whole circles. Okay. Number 3, circle the fraction on the number line that is the same as 1 whole. Draw a box around the fraction that is the same as 2 wholes. So I want to circle the fraction that is the same as 1 whole, and I want to draw a box around the fraction that is the same as 2 wholes. Okay, so really important, boys and girls, even if you know the math for this one, following the directions is really important. Okay, I see a lot of children who will just put a dot or who will circle both of them. Please make sure that you're following all the directions and doing what is being asked of you. Okay, so the first one says circle the fraction that shows 1 whole. Well, I know the relationship between numerators and denominators. The numerator tells me how many parts I'm counting. The denominator tells me how many parts are equal in 1 whole. If I want 1 whole, then I want my numerator and my denominator to be the same. That way I'm counting all the parts that are in my whole. So my 4/4 would show me 1 whole. Okay, and if it takes 4 parts to make a whole and I want to show 2 wholes, then I know that I want 8 parts, 4 and 4. So 8/4 would show me 2 wholes. Okay. Each square is 1 whole. Write a whole number and a fraction for the parts that are shaded. Number 4, we'll start with the whole. Okay, I see that there's 3 whole squares. 1, 2, 3. So my whole number is a 3. Okay, and here I want to be very careful. One of the big misconceptions is that children will write 12 as the denominator. Okay, where do you think they're getting the 12 from? That's right, they're counting all the parts. Okay, let's erase that, because we know that when we're looking for our denominator, we're focusing just on 1 whole and we're counting how many parts makes that 1 whole. So I see that there's 4 parts to make 1 whole. And now when I'm talking about the denominator, I'm going to count all the parts that are shaded. So we know that there's 1, 2, 3, 4 parts, 5, 6, 7, 8 parts, 9, 10, 11, 12 parts that are shaded. So 12/4. And again, I can see that connection with division if I divide the numerator by the denominator, and it gives me my whole. Okay, let's see if it works on number 5. Number 5, we have 1, 2, 3, 4, 5, 6, 7, 8 parts in 1 whole. Remember, we're focusing on that 1 whole to find our denominator. Okay, and for the numerator, we're counting all the parts. So if I have 8 parts in my first one and 8 parts in my second one, I have 16 parts. Okay, let's use division to see if we get the correct number of wholes. I have 16 parts, and I'm dividing them into 8 parts to make each whole. So 16 divided by 8 is 2, and that sure works. My model shows me 2 whole squares. Okay. And the last one, Belle runs 16 times around a track that measures 1/4 mile long. Write a fraction that shows the distance that Belle runs. How many whole miles does Belle run? Well, for this one, I think I'm going to make a number line. You know, she's running, she's using miles, so I'm going to make a number line, and I'm going to do it here. Let's do it here so we have enough space, okay? And I know that my number line, I'm going to start at 0. And from 0 to 1, how many equal spaces should I have from 0 to 1? Okay, that's right. I should have 4. If I take a look at my denominator, there's 4 equal parts in 1 whole mile. So I'm going to make my 1 here, okay? And now I'm going to divide this into 4 equal parts. Remember, we're not drawing 4 lines, we're drawing 4 equal parts. We want the parts to be. So I'm going to split it in half first, and then here and here. So that shows me fourths. I know that there's 1, 2, 3, 4 fourths. Okay, and I know that she does this 16 times. So I have 1, 2, 3, 4 parts, and I want to extend my number line to show 16 of those parts. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So let's take a look. Every time that I have 4 parts, I have a hole. So 1, 2, 3, 4, that's 1 hole. 1, 2, 3, 4, that would be 2 holes. 1, 2, 3, 4, that's 3 holes. And then 1, 2, 3, 4, 4 whole miles. Okay, and I'm going to use a different color ink, and we're going to do the fractions for this. We're going to fill this in. So we start at 0/4. Okay, this one would be 1/4. Okay, 2/4, 3/4, and now my 4/4 should line up with 1 whole, and it does. Okay, now we're going to continue counting by fourths. And my 8/4, because 8 divided by 4 is 2, should line up with my 2 whole miles. Still counting by fourths. I am adding 1 extra part on my numerator each time that I count. And now look at that, 3 whole miles, 3 whole miles is 12/4. 12 divided by 4 is 3. (15/4), and we stop at 16/4. Okay, and what do you notice about 16/4 and 4 whole miles? Well, I noticed that 16 divided by 4, we're putting it into groups of 4, equals 4. So how many whole miles did Belle run? She ran 4 miles. Okay, good job today, boys and girls. Make sure that you listen to any part of this video again. If you're still having a hard time, feel free to email me. My email is on the bottom of the screen. Okay, and today's homework is page 141 and 142 in your homework book. Okay, see you later.